Dear attendants and panelists and speakers, welcome again to the second session of the second day of the Istanbul Bridge Conference. And this session will be about joints and bearings. And our first presenter is Mr. Simon Hoffman, and he will explain us on their works on application of ETEC 032 as a new level of expansion joint assessment. And Mr. Simon is here, I think. Can you unmute?
Good morning.
Good morning.
So, thank you very much for the invitation and for the chance to present here about the European Technical Approval Guideline 032 for expansion joints. I try to start my presentation. Oh, that didn't work. And okay. In fact, I struggle to share my presentation. Just a second. Recording YouTube for more. Live on YouTube, view, stop video, no.
There's a share screen in the bottom of the screen.
Normally there's a share screen, but not in this. Ah, here we go. Here we go. So let me take this one here. Sorry that it takes me a second.
Yeah, no problem.
Share screen. Screen. Screen 2. Screen 2. Share. And now I hope you see still the wrong screen. Okay. I think now you. This is really.
Ever seen the presenter view actually?
No, this is not the way I expected. So we try that one. That way. Okay. Still doesn't work. Okay, stop share. Just a second. I need to change the screen. So we change that.
You can swap from PowerPoint if you want.
Share. And
yes,
now it should work.
Okay. Yes, this would work. Yes.
Perfect. Sorry that it took me a second. So once again, my name is Simon Hoffman. I'm a Chief Technical Officer for Magiba, I think a well-known company for bridge bearing and expansion joints. And I have the chance to introduce you to the European Technical Approval Guideline 032. First of all, I want to tell you something about the current status of ETEC 032 and the EADs, which has substituted in the meantime ETEC 032. Then there are some ETAs, so European Technical Assessments, already available for expansion joints that I want to introduce to you, and in particular, how to deal with these ETAs. And then I will show you some examples for assessments according to EADs, in particular in regard of modular expansion joints, and in the end conclude. So where is CE marking applicable? Because that's maybe the most important point regarding ETEC 032, that you have CE marked expansion joints, which is rather new. The CE marking comes either through harmonized European standards, so HENs, or which are introduced by CEN, or are coming through ETECs or EADs issued by EOSA. So this is all about possible members, or this applies to all members in the European member states. And in addition to associated members like Turkey, Croatia, Iceland, Norway, and Switzerland. So in the end, this applies to the largest economic area worldwide, not only for building products, but for products in general. So in the end, the CE marking will look pretty much like we see it here on in relation to ETEC 170612, which was the earliest or the first European technical assessment granted for steel expansion joints. The rules for the CE marking itself is given in the construction product regulation. I will refer to this CPR many more times within this presentations. And as I said, it's always based on the so-called harmonized European specification, which can be a harmonized standard or a European assessment document. Yeah? In our case, it's a European assessment document, the so-called EAD. And in the end, you use the EAD for rules regarding the assessment to get the European technical assessment granted. So the application of the EAD will lead you to an ETA. Nevertheless, different to earlier European technical approvals, you can read the ETA, the European technical assessment, only in combination with the EAD. Because much of the information that you need to know for the application of the ETA is given in the EAD and not anymore completely in the European technical approval. In the end, once the EAD is cited in the official journal by the European Commission or by the European Union, a notified body can be notified according to this EAD and can certify based on a granted ETA for that product, which gives then the basis for the declaration of performance, so-called DOP. You see, this is a rather large package that you need to consider, and the CE marking by itself does not qualify the product. You need to see it in combination with the ETA, together with the EAD, and with a declaration of performance. Many of you might have heard about the European Technical Approval Guideline 032, which was introduced in May 2013, and still based on the Construction Products Directive, which was applicable until July 2013. Since July 2013, all construction products in Europe are regulated by the so-called Construction Product Regulation, which calls for a quite different format, so that it was really difficult to apply ETEC 032 according to the Construction Product Regulation. Since the 28th of October, so very recently, all parts of ETEC 032 have been substituted by EADs, which now fully comply with the Construction Product Regulation and gives you a proper basis. By this transition to an EAD, certain clarifications of the ETEC 032 have been available. And so now we have a much better basis with the EAD compared to the ETEC 032, even though the technical teaching of ETEC 032 keeps the same in EAD, but now in a much more clear and, to my point of view, much better form. As I said, there have been some ETAs being granted already in Europe. But all of these relate only to flexible plug expansion joints, so-called TORMA joints, and related to former ETEC 032 part 3 with polymer filling, like for example the polyflex joint supplied by Mahtab. There have been since 2017 various ETAs on nosing expansion joints, so single seal expansion joints with and without noise reducing elements. So currently movement capacity is covered with ETA only to a range of about 100 millimeter, maximum 135 millimeter longitudinal movement capacity. There are other approvals in Germany, for example, in Europe, for example, in Germany, according to TLTPFU, or based on RVS in Austria and many other countries in Europe. So, according to approvals that we find in Europe, all common types of expansion joints, including mat, cantilever, and supported, so sliding finger joints, and of course modular joints, which cover the largest movements, even much more effectively than 1.4 meter longitudinal movement capacity, as you know, is required for Kanakale Bridge, for example. And having a look on the application of existing ETAs is an important chapter for me, or to my point of view, as it is not that easy to read an ETA. Not as easy as the former European technical approvals in the past. First of all, it's up to the client, it's up to the user to decide if the product shown in the ETA or assessed in the ETA covers the needs of the client. It's not an approval, so the ETA does not tell you it works for your application. The client needs to decide, and therefore it's imminent that the client is able to read the performance and see if it's if the used assessment fulfills his national requirements. And for example, in this regard, partial safety factors are explicitly important, as these partial safety factors vary in different member states of the European Union and beyond. Like for example, gamma M0 might be 1.0 in some countries, but for example in Germany it's required to be 1.1. So you need these partial safety factor, and you need to compare them to the needs in your in the country of application. And therefore it's not only important to have the value, but to have a clear reference. You need to know which are these values and where you can find the national applicable values, like shown in our ETA issued already in July 2017. Unfortunately, in many ETAs issued in the meantime, like this one issued by DEBT, you cannot find these values, and therefore you will not be able to check if that ETA is applicable in your country. Here, there was no value given. In other ETAs, like here issued from CPC, there's no clear reference, and even the notation used as alpha GI is not listed in any Eurocode. Same as many other aspects here, you can assume that AC might be a safety factor for concrete, but obviously not in the notation of Eurocodes. So you need clarity, this information needs to be clear, and the user needs to check it. Then As well, we find in some ETAs contradiction to the given specification by ETEC 032 or the EADs. Like for the corrosion protection, it's clearly required in the scope of the EAD, for example, that only C4 and C5 shall apply for expansion joints. And this information should be given in Table 1, which shows the essential characteristics of the product. While you find in some ETAs various information that it's optional. No, corrosion protection is not optional for expansion joints, like that one issued by Tassos in Prague, or again in this ETA by CPC, where there's C1, C2, C3, C5, and C5I. This is not correct in regard of ETEC 032. So you need to check the ETA really in detail. Then even within the most experienced technical assessment bodies granting the ETAs, we find some deviations which are due to missing clear guidelines through ETEC 032, respectively better and more clear guidelines by the EAD. Like we find one ETA with a maximum gap of 120 millimeters, while it is clearly said that the movement capacity cannot be increased by noise reduction elements, reducing elements like sinus plates, and likewise the gap is clearly limited to 100 millimeters. Fortunately, by the EADs, we will have much clearer guidance through the EADs, and therefore it is to be expected that quality of the ETAs will get much better in the future. And I highly recommend to apply ETAs or to use products based on ETAs which have been assessed according to the EAD and not ETEC 032. But you see, this is a rather complex process, and this calls obviously for highest competence in this niche, in this regard, and independency of the process, because the more this is related to only one body, which is the case for some ETAs, where the testing, the checking, the assessment, and later on the certification is all in one hand, and so it's all related between the manufacturer or the supplier of the product and one other body. To be frank, some of these technical assessment bodies have a clear lack of experience in that regard, as we see partially already in the ETAs or in the results by the ETAs. And therefore, we definitely recommend to distribute the single task through the most competent experts in their particular field, which is never within one hand. So, for example, we have most of the testing through MPI Karlsruhe, which has a 100 years history in such testing, much in relation with expansion joints. Then for checking FCP in Vienna, which is a highly experienced partner, then the ETAs are assessed and later on granted by OEB, which through Georg Kohlmeier, who has a chair in the working group responsible for the transition of ETEC 032 to the EADs. And then we have two very experienced notified bodies through BCT and MPH Stuttgart, which are long-term certification bodies according to German and Austrian codes for expansion joints. But in addition, even though ETEC 032 has been introduced by many countries through particular standards, like in Germany, Netherlands, Austria, Czech Republic, and Romania, to name only a few of them. It is necessary not only to introduce it, but to add some information, because an EAD and ETA never gives any information about the use, the installation, and the maintenance. So you really need, or we highly recommend, to introduce national standards, giving clear guidance of the performance the client will need, giving clear guidance on the applicable partial safety factors, for example, and taking care of the aspects not covered in the ETA or the EAD. Having a look on the assessment, first of all,
you have 7 minutes left.
How many? 10 minutes or 5 minutes?
7.
7 minutes. Yes. Okay. Well, I managed. Thank you very much. So, first of all, through the calculations that we've done and the projects that we supplied with expansion joints assessed and calculated according to ETEC 032, we see that we have created much more robust systems. So for modular expansion joints, the governing point is the distance of the support bars. And if we work on default values for the calculation, we end up at only half the distance. So much more robust. On cantilever finger joints compared to TLT, PFU, and ESTO, we need about 20 to 30% thicker finger plates. In order to make the design more efficient, more economic, you can analyze very much in detail by dynamic assessment and field tests the dynamic behavior and reduce, for example, the dynamic application factor and upswing factors. But this is a high demanding test which needs a lot of competence in regard of measurement and data interpretation, as well as statistical evaluation of the test results. Even more important to my our point of view is to have really experienced partners in the field of evaluation of applicable detail categories, because we see some undermining by false evaluation, as for example, or here one example where we have a fillet weld of a detail at highest stress concentration within the modular expansion joint, which is classified according to EN 1993-1-9 as fatigue category 80, while it was claimed that this should be higher than fatigue category 160, while 160 is the highest category available in that code. And it was claimed on the basis of enhancement on HFMI, which is clearly defined with a limit according to the IIW guideline to a fatigue category 125. And furthermore, this was all done based on 3 run-out tests on 2 million load cycles, while run-out tests do not serve for standard deviation. It do not allow for proper evaluation according to existing codes and guidelines. And so really be very careful in this regard, because we saw much misleading analysis in that regard. New and there's nothing available in other codes are statistic tests in terms of relaxation and creep of components, even though for modular joints this is a very important aspect, as this is important for a proper pre-stress in the center beam to joist connection. Still, it needs a strong understanding of the material background and long-time experience with the components that you apply and test in this regard. These components serve as well for movement, and rather new by ETEC 032 is a combined test where you first have a wear test on that component, and later and after simulating 25 years of service, up to 25 years of service, you do a subsequent test with 5,000 cycles on full fatigue load, which is a high demand and very well representing the real kinematics if you have special equipment that needs to be developed in that regard. As well, assessed for fatigue are, for example, the anchors, which are rather complex, and for example, only stud connection can be assessed based on EN 1994-2, and while most anchor systems really needs to be tested. Still, this needs profound expertise in structural testing, as we find it, for example, in MPA Karlsruhe. As well, water tightness is assessed by a special test set up in relation of the movement and cleaning capacity of the, for example, for modular joints and single seal nosing joints. One of the most demanding, if it comes to really big joints, is a movement capacity test, as you will need to test modular joints really for the largest applicable type covered by the ETA. So this means in our case, in LR18 here with noise reduction sinus plates type LR-LS, so with 180 millimeter of longitudinal movement capacity, then we tested as well the smallest one, which is obviously for modular joint one with 2 gaps. The full modular design of our joints allowed us to interpolate in between the sizes. For many other types, you would need to test all single sizes. So let me conclude. EADs have in the meantime substituted ETEC 032. So these EADs, available now since October 28th of this year, are the most modern specification we find for expansion joints for brokerages. Fortunately, this makes life much easier to comply now with the construction product regulation, and we really have a very good setup in that regard, and we will be able to issue much more clear and much better ETAs in the future, in the very near future for Mahtab. In general, the assessment, which is unique in terms of the various aspects covered, and on the level of safety, we reach really durable expansion joints, which are unique throughout widely used standards. Still, the EADs lack in terms of rules covering installation, the use and the maintenance of the joints. And therefore, it requires national additional specifications like coming revision of TLT PFU, or in Austria, for example, UNORM B 4031, to cover this aspect and give clear guidance to the user what to check within the ETA in the performance of the joint. Then the test itself and the interpretation of the data is highly demanding, and it's a big challenge even for very long experienced experts in our niche. And therefore, it's very important to involve these experts and be very critical in regard of the measured data and its interpretation. And in this way, we highly recommend to distribute this task throughout various experts in this niche to use the highest available competence in this regard. In the end, by the ETAs, based on EADs, which has now substituted ETEC 032, we can really create a new level in safety and performance, and as well in durability of expansion joints. So thank you very much for your attention. Sorry that it took me a little bit to get the presentation under control or the technical access through an online presentation, and I'm open to your questions. You're still with me? Hello?
Thank you, Mr. Simon, for this informative presentation on the application of ETEC 032 as a new level of joint assessments. And we have a few questions from our audience, if you're available for them.
Of course.
And one of the comments is that you have mentioned the partial factors, and the comment is that most of the time there is no information in national annexes about these partial factors. And countries like Turkey have difficulties in deciding on these values. And considering Turkey has on one side mountains with lots of snow, and on the other side too much sunshine at seasides, this might result in very diverse or differences even within a country. So do you have any comments on the effect of different geographical conditions within a country?
Yes, in fact, I fully share the statement that this is somehow troublesome. Yeah? That we have such a high diversity of safety factors. Magiba, for example, tries to address this by choosing for the assessment the highest or the most conservative values throughout all member states. Yeah, like you saw in my presentation that we used for gamma M0 factor 1.1, which is the highest safety factor you find throughout Europe. And to be on the safe side, and this makes sense for us because we supply throughout Europe, and it would not be effective for us to issue an ETA for every single member state. And to be on the safe side, ensure that that this high safety level is covered. Yeah, and effectively, it will not make that much difference for the overall design. But if you want to ensure that high safety level, you will need to look for the highest safety values available.
Thank you. And they also add that the differences in high-speed train bridges and highway bridges may also make a difference, but I think a similar approach can be followed in that case.
Yes. ETEC 032 covers only expansion joints for roadway bridges. Yeah.
So it covers only roadway. Thank you. Thank you, Mr. Simon, for this presentation and the answers.
Okay.
Okay, I'm just now stopping your sharing, if you're okay.
Very good. Thank you very much, and have a nice conference.
Dear participants, our next presentation will be about the new iconic crossing across the Scioto River, Dublin-Ohio connectivity and inclusivity by the writers Mahtab, Hamdi and Andrea Tognetti. And both of the authors are in the audience, but I think Mr. Mahtab will present this study. So Mr. Hamdi, can you hear me?
Hello, yeah. This is Mahtab.
Okay, Ms. Hamdi, sorry. So we can hear you.
Hamdi,
You can share your screen.
I can hear you. Andrea is also here. I can see.
Hello, everybody.
Okay.
Hey, Mr. Andrea.
Can I share my screen?
Yes, yes, you can.
Okay.
There is a share button in the bottom of the screen.
Yes. Okay, now I have. Can you see the?
Yes, we can see your presentation.
Okay, perfect.
And we can hear you as well.
Hello everybody. First of all, I would like to thank you for giving us this opportunity to participate and present our paper in this conference. My name is Mahtab Hamdi from Redaeli company. I and my colleague Andrea Tonietti have prepared this paper and presentation on Scioto River footbridge in Dublin, Ohio, United States. Andrea is the project manager and engineer responsible of the project and also responsible for the site activities. That's why we did this together, and we are going to present it together as well. The Scioto River footbridge is located in Dublin, Ohio, and has been realized by City of Dublin. The architecture design is from Ender Studio. The engineering design are T-Violin International for the structure and SBPNY for the erection sequence. Genesis Structure and Michael Baker were the consultants. And the main contractor is Kokosin Construction, while our company, Redaeli, has manufactured, supplied, and installed the cable systems and accessories. Here you see the location of the bridge in Ohio, United States. The residents of Dublin have named this iconic bridge as the Dublin Link because it links together the two parts of the city. Dublin Historic at the left to commercial, residential, and retail on the river's eastern side. The deputy city manager of Dublin mentioned it serves as landmark for the city of Dublin, representing connectivity and inclusivity. The bridge is characterized by a needle-shaped concrete mast and S-shaped deck, and the cable hangers that are connected to only one side of the deck. The total length of the bridge is 232 meters, and the suspended span length is 153. The mast height is 52 meters, and the width of the deck is 4.3 meters. For this project, Redaeli has provided the entire cable system, including clamps and spherical pins and washers. Here you see the details of cable systems. The main cable and tie-down cable are full locked coil cables with diameter of 120 millimeters. Other cables are 50, 32, and 21 millimeter full locked coil cables. The main cable is with fixed fork sockets at both ends. For tie-down cable, there is an adjustable cylindrical socket with spherical nut and washer, and all the hangers and restrainer cables have a fixed fork at one side and adjustable fork socket at the other side. Here you see the spherical pins, and here are two types of clamps which connect hangers to main cables. The spherical washer in the lower right corner of the page are the cylindrical sockets on tie-down cables, and they have been provided with welded slots to be fixed to the structure. Well, for the lower anchorages of hangers, in order to accommodate any rotations between the cable sockets and the anchor plates under live load events, the spherical bearings were necessary. The first proposal of Redaelli was using spherical bearings like Schaeffler bearing, as you see in the photo in the page center. Since the anchor plates of the deck were partially already produced, in order to apply this solution, major modifications were needed. Therefore, the first proposal has been discarded. Actually, the second proposal was also another commercial bearing which has been discarded for time issues. Well, subsequently, Redaelli designed and proposed a spherical joint between the socket and the anchor plate. But this solution has been rejected because of visual and architectural concerns. And finally, Redaelli designed and manufactured a set of pins that you see in the lower right corner with a spherical shape in high strength stainless steel, which bear against a spherical isolating washer. And this solution has been accepted because it had minor modification in the structure and totally solved the problem. Well, the structure under the live load has significant movement, and this movement changes the overall geometry of the bridge. In order to simulate the cable during the service life and to understand their behavior in such high and eccentric fatigue loading circumstances, axial and bending fatigue test was carried out on FLC 120 and FLC 32 cables. Here you see the test on FLC 32 cable. This test was done on a specimen with a permanent socket in Kipcon laboratory in the Ruhr University of Bochum, Germany, with horizontal, as you see, with horizontal pulling machine. In the photos, you can see the setup of the test with a pulsatory axial load machine, lateral actuator, data logger, wire Brock accelerometer, and measurement devices. For this test, Redaelli have designed and provided the connection plates and saddle for the lateral actuator together with the procedure to perform the tests. In this test, also the spherical pins was included. And as it is visible in the picture, the test was successful, and after the test, the element was free of any sign of damage. Here we have the test parameters. On the FLC 32 cable, 2 million cycles with delta force of 78 kilonewton has been applied. At each cycle, the bending angle was minus plus 0.6 degrees. The maximum acceptable amount of broken wire is 2%. It means if the cable is made of 100 wires, only 2 wires could be damaged or broken after finishing the fatigue test. And after the end of fatigue test on the cable, a braking test has been carried out. The braking test of this fatigued cable should be at least 95% of the original braking force. It means if the cable breaks before 95% of minimum braking load, the test is failed. And in our case, luckily, the results were satisfactory. The fatigue test, here you see the fatigue test on FLC 120 meter. It means that the full locked coil cable with 120 millimeter. It was carried out at MPA laboratory in Braunschweig in Germany with a vertical pulling machine, as you see, on a specimen with a permanent socket and a dummy cylindrical socket. Here we have the equipment, same as the other laboratory. Again, Redaelli supplied the connection plates, supplied and designed the connection plates, tools and saddles for lateral actuators, together with the test procedure. On FLC 120 cable, 1 million cycles with delta force of 500 kilonewton is applied. Again, at each cycle, the bending angle was minus plus 0.6 degrees. And same as before, the maximum acceptable broken wire is 2% and the residual braking load is 95% of the original minimum braking load. The starting date of Redaelli activities on site was 12 June 2019, and the works finished on 21st November. Here you see the installation of tie-down cable. You see the activity of handling, uncoiling, and hanging the cables. In these two pictures, at the right, you see the installation of tensioning system for cylindrical sockets using 3 jacks, 3 hydraulic jacks with capacity of 120 each for a total pulling capacity of 360 tons. In order to give the stability to the structure, first, the tie-down cable has been tensioned, and afterwards, the 2 main cables were uncoiled and installed to the mast. And by using pulling devices and machineries, they have been attached to the lower anchor points. Of course, before installing the main cables, while the cables were lying on a wooden support, all clamps have been installed on the main cable. And in order to position the clamps, in Redaelli factory, longitudinal and transversal marks were made on the main cable to place the clamps in the correct position. Here are some photos of pinning the main cable. And installation of main cable. Well, during the cable installation, a strong rain significantly raised the level of water in the Scioto River, and it caused a flood and subsequently stopped the site activities for several days. Thanks to the quick thinking and immediate action of personnel on site, suitable wooden support was prepared before the flood hit. In the river side, the wooden supports were not enough. Therefore, the main cable has been hung to the deck, keeping the cable above out of the water to avoid possible damages. The last challenge was of the project was related to tensioning system of the hangars, where we had forked socket at both ends. Since the anchor plates had no room to connect to be connected to the tensioning system, Redaeli provided a specific design for tensioning system to help client to not modify anything on the steelworks. In this design, the tensioning system was connected to the directly to the permanent pins of TBF sockets, adjustable fork sockets, that were just a few millimeters longer than standard pins, without any visual and architectural issues. And as a result, the system worked perfectly. After all cables were installed, all hangers and tie-down cables have been tensioned by Redaeli personnel several times according to SPP procedure for tensioning. End of Redaeli site activities. Despite all challenges, the bridge construction were performed successfully. And of course, it was a testament to the close cooperation of engineers, contractors, suppliers, and the project owner. The completion of the Scioto River Bridge has been a remarkable achievement for all parties involved in the project, and it was another valuable experience in Redaeli records. Thank you so much for your attention. Now, if you have any question, I and Andrea are ready for answering.
Well, thank you, Ms. Mahtab, for this very informative presentation on the crossing across the Scioto River in Dublin-Ohio connectivity and inclusivity. And from our audience, we have several questions, actually. The questions is that, did you observe any adverse effect on connections at the break of wires during the fatigue tests? And did you stop the test or did you continue the test with broken wires?
Well, Andrea has directly observed the test. That's why I'm asking.
Hello, everybody. Yeah, we faced actually some wire breaks. We have made a free fatigue test on the 32 millimeter cables, and on the free test we had no one wire break on the 32 millimeter cable. So we had actually a really good behavior of the cable that even in Redaeli we didn't expect such a good behavior with this fatigue test. That was the first time performed both the axial and the bending fatigue test. While on the 120 millimeter cable, we have made two fatigue tests. On the first test, we have the maximum allowed breaking of the wires. So if I remember well, it was like 7 to 8 wires. But anyway, still in the maximum acceptable range. On the second test, we have modified a little bit just the setup of the test. So basically, we have moved a little bit the place where we are acting the lateral actuator, so the bending procedure, and just with this little modification, the number of wires that were breaking significantly dropped, and we had just a few wires broken on a 120 millimeter cable. So it has been a very good result. So we didn't have to stop the test in any case about this.
I see. Thank you, Mr. Andrea. And the other question, sure. The other question is that have you observed in the location of the wire breaks, like were they in the outer section or in the inner section, or they were totally random?
No, of course, the wire breaks basically occurred all just near the entrance of the cable in the socket, which is the let's say the point where we expected to have the majority of the wire breaks, because also from the calculation it was a place where the maximum stress happens on the wires. So because of the bending, and this also is because moving the position of the lateral actuator have significantly modified, let's say, the test setup, and therefore the number of wires that were breaking. So yeah, all the broken wires were just at the exit from the sockets.
I see. Thank you, Mr. Andrea.
Yeah, only in the position.
Very informative answers. Looks like we don't have any other questions from the audience to Mr. Mahtab or Andrea.
Thank you so much.
And now we will continue with the final speaker of this second session. And now Ms. Elif Yıldırım will talk about the bearing installation topic, if is available now.
Yes, I'm here.
Thank you.
Hello, everyone again. I will share my screen. Share the screen here. Do you see my screen?
Yes, we can see yours.
Is it full screen, right?
It's not full screen now, but
Not full screen? It should be.
okay, now it is. Okay, now it is.
It
Maybe
is-
there's a little bit delay.
Okay.
Okay, now.
Hello, everyone. Today I will present you structural pot bearings and expansion joints of bottom bridge. I will mention location of bottom bridge, balance cantilever bridge construction method used for bottom, partial collapse of the bridge and its reconstruction, and finally I will mention pot bearings and modular expansion joints of bottom bridge. Aim of the bridge is to replace old bottom bridge because the old one will be submerged when pervary dam reservoir increase. New bridge will also reduce the travel time between pervary and Siirt. The travel time between one and pervary decreased from about 5 hours and nearly 2 hours on a safety and comfortable route. On the left side, you can see where the bridge is located. On the right side, we see how small is the old one compared to the new one. The last picture is from the opening ceremony of the bridge on October 11th. The bridge length is 450 meters and 40-meter width. Bottom bridge has special features. It has a longest central span at 210 meters among balance cantilever bridges in Turkey. And it is the highest bridge in Turkey with a 165-meter height. I would like to mention a little custom-place balance cantilever construction method. This is the common bridge construction method where the ground isn't suitable for scaffolding due to water or deep valley. Each pier segment should be built on both sides of a pier at the same time. During the construction of segmental concrete bridges using the balance cantilever method, it is necessary to guarantee the stability of the cantilever arms on their pier. Here we see pictures from construction stages of bottom bridge. In December 2017, unfortunately, bottom bridge is collapsed during the construction phase. Here we see pictures of catastrophic event. After the collapse, some part of Pier 1 is cut deliberately and Pier 1 had to be rebuilt. I would like to show you a video from the opening ceremony of the bridge. Here we see how huge is the bridge. And I would like to mention about the pot bearings. Pot bearings are used for the bridges which are exposed to different rotational and displacement effects, and they are designed according to different standards such as EN and Scioto LRFD. Pot bearings consist of a steel pot, an elastomeric pad in this pot, and steel element that transfers the vertical load and rotational effects of the superstructure to the substructure. And we have different pot bearings types. And one is free sliding pot bearings, which can move any direction and carry a vertical load on the bearing. And guided pot bearings are moved in one direction only and can carry a vertical loads. Fixed pot bearings cannot move any direction, but absolutely carry the vertical loads on the bearing. Here we see a 3D model of the pot bearings we designed for the bottom bridge. This pot bearing can move in a longitudinal direction only. It cannot move transverse direction. It can carry nearly 22 tons in vertical direction, and as I said, it cannot move in transverse direction, but can carry 8 tons in horizontal 8 tons horizontal load. And this pot bearings have a CE mark according to EN standards. And we see here some pictures from our factory and installation pictures from the site. And here we see where the pot bearings are placed on the abutments, and one pot bearings weight 6.3 tons. And here in bottom bridge we used two pot bearings at each abutment, so we have totally 4 pot bearings. We also provided modular expansion joints to a bottom bridge. Modular expansion joints are metallic expansion joints, and these expansion joints have 400 millimeter plus and minus 400 millimeter movement capacity. And this modular expansion joints have 8 gaps. Here we see a 3D model of expansion joint and where it is placed on the bridge. Here we have two expansion joints on each abutment. Here we see only one of them. And I would like to show you pictures from the installation installation of the expansion joints. It is really huge and it is placed on the abutments. And close pictures from the joint. And thank you very much for listening to me. And that's all about my presentation. Thank you.
Thank you, Ms. Elif Yıldırım, again for this presentation about the bearing installation of the bridge. And do we have any questions? Let's wait for a few seconds to see if we have any questions from the. Looks like we don't have any questions from the audience, so.
Thank you, Dan, listening to me.
Thank you.
I sent a question via chat. Maybe still raise that question?
Maybe you sent. So I cannot see the question.
Maybe it did not
I think you have
transmit.
sent.
Yeah, to.
It's directly.
I sent it privately to Alkana. I would like to know which gave the basis for the design of the modular expansion joints. Oops.
So you want to know? Sorry, I couldn't catch the question. The code, right? Okay. So, Ms. Elif, he's asking about which reference code did you use during your designs and installations? H2LRFD. Okay, thank you. Yeah, so which code gave basis for design of the modular joints, and you have used the H2LRFD code. Thank you. Do we have any other questions from the speakers? Yes, looks like we don't have any other questions. Thanks again, Ms. Yıldırım, for the presentation.
Thank
now
you.
we will have another break, another commercial break, and we will come together at 10 past 13 for the third session about the construction. So hope to meet with you in 1:10 p.m. Thank you.
Possibile, ma guarda, prima di 17 ore chiama Elif, gente, gli dice ho già parlato con Marchesi, 18, 19, 18, cerco di fare il possibile, però anche voi mi avete, chiamo venerdì, sta finendo venerdì.
Grande, grande il partner.
Anzi, l'ha chiamato venerdì, Marco Marchesi, cosa che faccio allora?
BridgeWiz has been established in New York and expanded to the capital of Turkey, Ankara. As BridgeWiz, we provide reliable and affordable engineering services. Our workforce has more than 70% women in the team. Consulting and optimization, detailed evaluation of joints and bearings, condition assessment and health monitoring, and bridge engineering IT support are the provided services of the company. BridgeWiz Engineering is also a research and the policy of one of the top universities in Turkey, which researching joints, bearings, and artificial intelligence-based bridge management systems. At the same time, BridgeWiz supplies educational and engineering tools through tutorials and smart BridgeWiz calculators. As BridgeWiz, we can provide custom tools for your company in the forms of mobile or personal computer application.
TİS, Türkiye'nin ilk ve tek izolatörü. Dünyada kullanılan en son teknoloji, en yeni deprem yalıtımı sistemi. Hastaneler, veri merkezleri, konutlar, köprüler, okul merkezleri, hatta tarihi yapılar, üst yapıyla temel arasına yerleştirilen TİS deprem izolatörleriyle şimdi daha güvenli, TİS teknolojik izolatör sistemleri yapılara güç katar, hayatlara güven verir.
Reinforced concrete is one of the most economical and durable construction materials on the planet. When properly designed and maintained, concrete structures can last hundreds of years. There are times when it makes sense to demolish and rebuild structures, but all too often, the service life of a structure due to the widespread effects of corrosion and deterioration. In the construction, the service life and preserving concrete structures is the most economical and sustainable activity that we can pursue. Proper maintenance and simple and cost-effective activities that defer the requirement for major concrete restoration. Preserving or reusing existing infrastructure is one of the most sustainable activities that facility management can implement by mitigating pollution, reducing solid waste, The Concrete Preservation Alliance consists of Vector Construction, Vector Corrosion Technology, Corrosion Services, and NDT Corporation. These four businesses have come together to create an informational website to promote sustainable practices in the construction industry. We hope the website will become a leading resource of information for owners and engineers who are interested in concrete preservation practices. We invite you to explore the pages of WeSafeStructures.info, where you will learn about the benefits of concrete and corrosion evaluation techniques and extending the life of corroding structures using coatings, overlays, cathodic protection, and other techniques. The Concrete Preservation Alliance or visit WeSafeStructures.info for more information.
invited to Istanbul Bridge Conference.
You are invited to the Istanbul Bridge Conference.
You are invited to the Istanbul Bridge Conference.
Hello, my name is Melike.
And I'm Dilara.
We are volunteer engineer for Istanbul Bridge Conference.
This year conference is going to be online, but in 2022 we hope to see you in Istanbul. Now let's discover the Scioto. Let's discover the Istanbul.
You are invited to the Istanbul Bridge Conference.
The special Turkish delight here, made of honey. We have grape grapeseed flavor, fig flavor, Nutella flavor, lemon, caramel pistachio, Oreo, caramel strawberry, honey pistachio, kiwi. Then also we have Nutella with nougat with angel hair. It's so good. Also we have here pistachio and pomegranate, and also I close it with pomegranate.
Köprü konferansına siz değerli insanlar davetlisiniz. Merhaba arkadaşlar, İstanbul Köprü.
İstanbul Köprü Konferansı'na davetlisiniz.
İstanbul Köprü Konferansı'nda
Good night.
You are invited to Istanbul Bridge Conference 2022.
You are invited to Istanbul Bridge Conference.
You are invited to Istanbul Bridge Conference.
Hello, greetings from Sheraton Istanbul Hotel Ataköy. You're invited to Bridge Conference in Istanbul.
İstanbul Köprü Konferansı'na Merhaba arkadaşlar, İstanbul Köprü Konferansı'na hepiniz davetlisiniz.
İstanbul Köprü Konferansı'na davetlisiniz.
You are invited to Istanbul Bridge Conference.
workforce has more than 70% women in the team. Consulting and optimization, detailed evaluation of joints and bearings, condition monitoring, and bridge engineering IT support are the provided services of the company. Bridgeways Engineering is also a research and development company in the Technopolis of one of the top universities in Turkey, which researching artificial intelligence-based bridge management systems. At the same time, Bridgeways educational and engineering tools through tutorials and smart Bridgeways calculators. As Bridgeways, we can provide custom tools for your mobile or personal computer application.
TİS, Türkiye'nin ilk ve tek yerli ve milli deprem izolatörü. Dünyada kullanılan en son teknoloji, en yeni deprem yalıtımı sistemi. Hastaneler, veri merkezleri, konutlar, köprüler, okullar, iş ve alışveriş merkezleri, hatta tarihi yapılar, üst yapıyla temel arasına yerleştirilen TİS deprem izolatörleriyle şimdi daha güvenli, şimdi daha sağlam. TİS teknolojik izolatör sistemleri. Yapılara güç katar, hayatlara güven verir.
It's one of the most economical and durable construction materials on the planet. When properly designed and maintained, concrete structures of years. There are times when it makes sense to demolish and rebuild structures, but all too often, the service life of a structure is unnecessarily cut short due to the widespread effects of corrosion and deterioration. In the construction industry, extending the service life and preserving concrete structures is the most economical and sustainable activity that we can pursue. Proper maintenance and periodic cleaning are simple and cost-effective activities that defer the requirement for major concrete risks. Preserving or reusing existing infrastructure is one of the most sustainable activities that facility management can implement by mitigating pollution, reducing solid waste, and conserving natural resources. The concrete preservation construction, Vector Corrosion Technologies, Vector Corrosion Services, and NDT Corporation. Promote sustainable practices in the construction industry. We hope the website will become a leader in practices. We invite you to explore the pages of WeSafeStructures.info. Concrete repair techniques and extending the life of corroding structures using coatings, overlays, and other techniques. Please contact the Concrete Preservation Alliance or visit WeSafeStructures.info.